All right, hi everyone. I wanted to go over your Unit 7 unit circle and graph project with you, just to make sure that all the directions are clear and you understand everything. So I'm going to go ahead and share my screen with you so you kind of get an idea of what's going on. All right, so my unit circle or graph project. So this is actually a 200-point project. Okay, so just so you know, it's a 200-point project. I'll explain how the points are worked out in a second. So first part, so it's a two-part project. Your first part's the unit circle, and the second part is a graphing portion. So your first part is all about the unit circle, okay? You should have a unit circle. If you don't have one, I will show you where to get one or where you can find one in Google Classroom. So it's super easy, okay? So you're going to use this circle. So here's a circle, just so you have an idea. So here's my circle. So here's my circle. So this is the unit circle that I'm using. You can find your unit circle in Google Classroom. Okay. So here's your Google Classroom. If you go to classwork, it's this very first one here at the top, this unit circle. Okay, so you all have access to it. So this is what it looks like. So here's your unit circle. Maybe there it is. Okay. So it gives you the degrees. It gives you your radians. It also gives you your sine and cosine, okay? All right, so you're using this unit circle to create your own unit circle, all right? Be creative, and I'll show you some examples in a second. Your display should include all the angles in degrees and radians, so all the angles that are shown on that picture need to also be on your unit circle. So the 0, the 30, the 45, the 60, the 90, all the way around, okay? So there should be 3 in each quadrant. And then, of course, your x-axis has 2 and your y-axis has 2. Okay, so please be sure the measures from measure the angles with a protractor to ensure accuracy of your scale representation. So there are 16 standard unit circle measurements. You must also include the sine, the cosine, the tangent, the cosecant, secant, and cotangent values for each angle. Okay, some of these are going to be undefined. That's okay. You just write that they're undefined. Okay, you're given the cosine and the sine in the unit circle itself, so you have to find the tangent, the cosecant, the secant, and the cotangent values. Okay, be creative, have fun. So again, it looks, some of these look like this. You know, you have a Ferris wheel, there's a flower, they made a turtle. You know, you really can kind of be creative with this. You don't have to do just one circle. If you wanted to do the solar system, you could do something like that too. Okay, again, be creative, have some fun with it, all right? So that's the first part, okay? The first part is graded like this. So your accuracy in radian, degrees, sine, cosine, tangent, cosecant, secant, and cotangent. There's 16 points apiece, again, because there's 16 measures for each one. So even if like the tangent of one of them is undefined, you still need to write that that tangent is undefined for that angle measure, okay? You get 5 points for being neat, organized, and I can read all the writing. You get 10 points for creativity. So these are kind of like freebies, okay? And 5 points for evidence of effort. So if you showed effort, it looks nice, you get these points here at the bottom, okay? So part 2, okay, so part 2 is your sine, cosine, tangent, secant, cosecant, and cotangent graphs. So you're going to create 3 functions with different amplitudes and phase shifts, vertical shifts, periods, and midlines. 1 for each of the functions, sine, cosine, and tangent, okay? Actually, don't even have to worry about these, non-existent, okay? So sine, cosine, and tangent. So you're going to use the parent function, and then you're going to create 3 different graphs. Okay, so I'll give you an example of one. You cannot use this one. So okay. You can do all of this right in Desmos, right? So if I were to do the sine function, so y equals sine of x. Okay, so there's my sine function. Now I'm going to make up another one. Let's go z, we'll go with y. Y equals 2 sine of 2 pi x plus 4 minus. So here is my original, and here is the graph that I just created, okay? So from here, you're going to need to identify the change, basically all the changes that occurred, okay? So your graph should have a different amplitude than a normal sine, cosine, or tangent function. Your graph should have a different phase shift. It should have a vertical shift. It should have a different period. It should have a different midline, okay? So remember, the midline is that center. Normally it's at x equals 0, or your x-axis, or y equals 0. My brain, okay? So in this case, given this graph, I have an amplitude of 2, okay? This gives me a different period. This gives me a phase shift of pi. I moved pi to the left. This gives me a new midline of y equals 3, -3, and I move down -3, okay? So you cannot use this graph, but all you have to do, okay, you can type right in here that this is amplitude is 2, phase shift is pi to the left, vertical shift is 3 down. Like, that's all you need to, you can type it right in here and then take a screenshot, okay? And then put that in a document. So that is really all that you need to do for this. Now you'll have to do one that's sine, one that's cosine, and one that's tangent, okay? And you'll need to include all of the amplitude, the phase shift, the frequency, all of that, okay? I didn't do all of it here, but that's what you'll need to do, okay? So you need to have the parent function labeled with the amplitude, the midline, the frequency, and the period, and you need to have your new function labeled, the amplitude of the new function, your midline, your frequency, your period, and your phase shifts, okay? Vertical and horizontal. Okay, graphs should be neat and easy to read, include 2 colors, one for each graph. So if you're using Desmos, it automatically creates 2 colors for you. So you can use Desmos as long as you included all that information, all right? So again, here's what mine looks like. Here's all these points. I graphed all the points with it. And then you can, of course, you can just type right in here, the amplitude of the cosine function is this. The amplitude of my new cosine function was this. You can do all of that, okay? All right. So then, of course, you have your grading. So you get 12 points for your accuracy for your sine graph, 12 for your cosine, and 12 for your tangent. So that means if you included everything that you need to include it in your sine graph, you get those 12 points. If you missed one, you lose a point. Okay, so like say that I missed my phase shift for my new sine graph. Okay, well, you lose a point. Now you're at 11 points. Okay, make sure you use 2 colors for each graph. That's 6 points right there, 2 points for each graph. And then it's neat and organized, legible labeling. Obviously, if you use Desmos, everything's typed and neatly written, so you don't even have to worry about that. Easy 5 points. Okay. And the evidence that you actually put in some effort, you didn't use the, the graph that I just used, that example, okay? So easy, another easy 5 points. This will, of course, all total up to a value of 200 points. If you miss one of these, you miss part of it, you'll lose points on the way, okay? So again, here's some examples below. You, of course, have access to this within Google Classroom. You can always ask me if you have any questions. And I believe that is everything. So have a great day.